Okay, so hi everyone. Yesterday I started analog circuit for HAL, right? So we discussed about you know we started with what? We started with amplifier modeling, right? We started with amplifier modeling. We started with amplifier modeling. Okay. As I said that the very first topic was in the syllabus diode and then BJT, MOSFET, and op-amp, right? So, but we started with op-amp because the question what we can expect in HAL examination will be quite easier, and you can solve questions from this topic, within less amount of time. Okay, so we started with amplifier modeling, and we discussed about how to model an amplifier. So we took three major blocks. Okay, three major blocks. The first block was source, right? Source. Here source was there, and here amplifier, and here the speaker was there, or you can say load, right? Load. So we got to know that how can you model an amplifier. So amplifier can be modeled with the help of dependent sources. So are you familiar with dependent sources, Srihari? Uh, how many
Yes,
kind of dependent sources are there?
voltage dependent current source, voltage current dependent current source,
Yes.
and
So yeah, there are
vice
four kind
versa.
of, yes, VC, VS, CCCS, okay, and CC VS you can say, and one more will be VC CS, right? So there are four kind of dependent sources are there, okay. So what we use to model an amplifier. So in the yesterday class, I have covered all those things. So once you will refer those things, you will come to know, okay, how we are deciding what kind of amplifier is given, okay, based on input and output nature of the signal, or based on input resistance and output resistance of the signal, okay, of the amplifier. So I summarizes here. So here was the voltage amplifier, or you can say VCVS, okay, and here I wrote input resistance of the amplifier, output resistance of the amplifier, right, and the parameter, okay. So VCVS and CCCS, this is voltage amplifier because in the input there is a voltage signal, right, and in the output also there is a voltage signal. In the input there would be current, and your signal will be of the form current, right, and output also will be the current only. And then in the third we discuss about VCCS, right. So you can see here the input is voltage and output will be current here, okay. And the last one was CCVS, right. So here again you can see the input is current and output is voltage. So can you tell me that what is the input resistance of voltage amplifier? Whether it will be high or low. Voltage amplifier. This is a voltage amplifier. This is a current amplifier. And this is what? This is the transconductance amplifier, and this will be the trans resistance amplifier. Okay. So here we will talk about the parameter. So once you will refer a study class, right, you will come to know everything. So voltage amplifier is having the high resistance and output resistance will be low. It will be having low resistance and high resistance, output resistance. Okay. In case of voltage controlled current source, which is transconductance amplifier, will be having input resistance as high, and output resistance will be also high. It will be low and low. And the trick I would like to tell here is that if there is a voltage control, right? If there is a voltage control, so always keep in mind the input resistance will be high. Okay, input resistance will be high. And if there is a current control, right? Input resistance will be low. This is just a trick to remember, okay? Remember this. Okay, Srihari, have you understood this?
Yes, sir. Yes, sir.
Yeah, voltage control means input resistance will be high, current control means input resistance will be low. And you know the internal resistance of voltage source and current sources. What is the internal resistance of a voltage source if it is ideal voltage source?
There is no
Yeah, means it is zero, right? So
right.
low resistance you can say. In case of current sources, if it is an ideal current source, then you can say high. So based on that, you can remember. See, somebody is going to ask you that what is the input resistance of voltage amplifier? So you have to say high, sir, right? And output resistance low, sir. So in HL examination, you can expect question like this. What is the input resistance of any amplifier and output resistance of any amplifier, like transconductance amplifier? Suppose in the question they have asked transconductance amplifier, transconductance amplifier is having, okay, is having mm, R in and R out, R out. In the options, they will be giving you high, low, low, high, 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 and low, low. So can you tell me which option will be correct? In case of transconductance amplifier, transconductance means what? Voltage to current converter, or you can say voltage control current source, right? Voltage control current source. So in case of transconductance amplifier, the R in will be high and R out will be low, right? So in this manner, you can decide whether the suppose input and output resistance are given, and if somebody is asking you what kind of amplifier is this, so you can decide directly, okay? So depending upon the input resistance and output resistance, you can decide what kind of amplifier is that, right?
Okay, the
And yesterday,
reason for this
yes,
is mentioned yesterday, right, sir?
yeah, these things I have discussed yesterday in the yesterday class, so you will get to know everything.
Okay, sure,
Uh,
sure.
yeah, so I think sir has shared the link as well. So in the group, you will find the link and you will understand everything, right? So I'm just going to start continue where I left the class yesterday. Okay.
Okay,
So I was talking about op-amp, that is operational amplifier, op-amp, right? And I told that I'm going to discuss op-amp in three basic modes. Okay. The first mode will be the negative feedback, right? Negative feedback. And second mode was the under negative feedback, we will discuss two kind of operations. One will be the linear operations and one will be non-linear operations, right? In case of non-linear operation, diode will be also present, okay, along with the op-amp. So diode is not taught at, right? So after op-amp, we will discuss diode applications, right? And then we will combine op-amp and diode, so you will understand better. So non-linear, right? Non-linear operations here we will discuss, and then open loop configuration we will discuss. So op-amp will behave like a comparator in case of open loop, right? If there is no feedback around the op-amp, so that op-amp behaves like a comparator, right? You know that comparator. Okay. And the last which I will be talking about is the positive feedback. Under positive feedback, how your op-amp behaves. So in that we will discuss about oscillators, right? Oscillator you can say. Smith trigger, right? Smith trigger is very important topic, right? And then we will discuss about multi-vibrator, multi-vibrator, right? So all these things I'm going to talk. So Srihari, you will find all these content in the previous class, right? And I also told that op-amp looks like this. The symbol of the op-amp looks like this. There will be a negative terminal, there will be positive terminal. And op-amp always takes the difference between two input, right? Suppose this is V1 and this is V2, and it has the open loop gain A. So output is going to be what? A times of difference between the input, that is V1 minus V2, right? Op-amp will be having the supply as well, okay, power supply, which will supply the power to the output, right? So op-amp always takes the difference of the two input, okay, remember this. This is a very important point, and it is your open loop condition, right? And you can see here, your output voltage is also depending upon the difference between, okay, the input, right? So again, you can say this is a kind of op-amp, okay, whose input resistance is what? Whose input resistance is very high and the output resistance is very low. So what kind of amplifier is this? Op-amp is what kind of amplifier? Can you tell me?
Voltage controlled
Op-amp.
voltage.
It is a voltage amplifier, right?
Right.
Yeah, it is a VS because it is having input resistance very high and output resistance very low, right? Already I have studied all these things, right? Just I am brushing up. Okay. Next. So this is what the op-amp is, and you know that this negative terminal is known as the inverting terminal, right? Inverting terminal, and this positive terminal is known as non-inverting terminal. Non-inverting terminal, right? And these things you have to keep in mind. These things are very, very important, right? So, and two more things you have to keep in mind, two more important assumptions, two more assumptions, while solving the questions, okay, under negative feedback. The first one you have to consider that the V inverting must be equal to V non-inverting, right? This is one condition, right? This condition is known as virtual short concept, right? But this condition is only applicable when your op-amp is not saturated, okay? If op-amp is saturated, then virtual short concept failed, right? Remember all this. So this is one kind of assumption for ideal op-amp, okay? For ideal op-amp. Ideal op-amp means the gain is pretty high, the open loop gain is pretty high, okay? uh, 10 raised to power 6 you can say. And second assumption you have to consider here is the op-amp does not take any current, right? Does not, op-amp does not draw any current, okay? Draw any current. Understand? Why op-amp does not take any current? Can you tell me?
The input resistance very high.
Yeah, yes, yeah. So I'm talking about ideal op-amp, remember? Ideal op-amp, okay? And these are the two important realistic assumptions which you have to keep in mind. Okay, so you would be able to solve the problem, okay, any problem. So we will take various problems, okay.
Okay.
So your op-amp will take difference of input. Yeah, op-amp is also known as the high gain differential amplifier. Op-amp is also known as, op-amp is also known as, right, known as high gain differential amplifier, right? High gain differential amplifier. Why we call it differential? Because it takes difference of the two input, right? Differential amplifier. This is very, very important. So for ideal op-amp, you have to consider the open loop gain is pretty high, input resistance is infinite, and output resistance is 0. Okay. So so with the help of these two assumptions, we can take now few examples. So yesterday we took some examples. Again, I'm going to take some examples, right? So the very first example I'm just going to take here is that this is op-amp, right? This is the op-amp, okay? And we will take the example under negative feedback. So don't bother about positive feedback and all. This is plus minus, right? You can draw the circuit with me and start solving the question. So you have to learn how I'm approaching the problem, right? From these seasons. Yes. This is a problem, very good problem, right? And this is output, okay? And it has 3K, as a feedback, and it is a 5K resistance. So welcome, Surajit. So this is a first problem. What I'm taking here is, have you noted down this problem? And this is a 2 volt, okay, supply. So Surajit and both of you, can you tell me what kind of amplifier is this? By looking at whether it is non-inverting amplifier or inverting amplifier. You have to find this guy, okay, output. Very easy problem.
Non-inverting?
Yes. Yes, non-inverting. Why? Because the input is connected to the non-inverting non-inverting terminal, and now you have to find the output. So I have told you two assumptions. The first assumption I have told you that the potential at this terminal, right? Potential at this terminal and the potential at this terminal will be same. So what will be the potential at this? This will be 2 volt, right? 2 volt, okay? And this 2 volt will be across 5, okay? And as I told you that the op-amp does not take any current, so no current will be flowing. So 3K and 5K will be in series, right? Not in parallel. It will be in series like this. Okay, it is grounded, and this is 5K and this is 3K. And this is your V out. And the voltage across 5K is how much? कितना है देखो? 2 volt, right? So what is unknown? V naught is unknown. So what you can apply here? You can apply the voltage division rule, right? Directly you can apply the voltage division rule. So your V out, I mean, you can say that your V out will be what? So you can say 2 volt equal to क्या हो जाएगा यहाँ पर 5 into V naught upon 8, right? So this gives you V naught equal to 16 by 5. Understand, both of you, how I have solved this? You can solve this question by applying KCL at this point as well, right? If you think KCL, you are happy with KCL, so you can apply KCL, right? The current, outgoing current you can consider, and you can get the answer. So this is the method 1, what I'm telling you, and this method works very rapidly. You can solve any kind of questions. So both of you, have you understood this, the way I'm solving the question, right?
Sure, sir.
Yeah, this is how you have to solve questions. So two assumptions in the question, they will mention op-amp is ideal, right? Op-amp is ideal. Next problem I'm just going to take here is that you can note down the problem here. See how I'm solving the problem, and you have to learn mainly the problem solving technique. This is the resistance here, and there is again one resistance, okay? And here one more resistance is there. Yesterday I solved this problem just for Sri Hari. I'm solving this problem again, right? V naught, this is 2K, okay, 2K, and this is 1K, okay, and here one source is connected, that is here is a source, that is 2 sine t, that is 2 sine t, okay. So what you have to find here is that you have to find the I naught. What you have to find? You have to find this current, I naught. So can you give a try, guys? Both of you, can you give try? Please try this question. Consider that the op-amp is ideal. If nothing is mentioned in the question, so you have to consider the op-amp is ideal. Op-amp is ideal. Ideal, right? Op-amp is ideal means what? It will not take any current. because input resistance will be quite high. Okay, so I think you guys have got the answer. Seriously, have you tried this question, Surajit? See,
Sorry, -8/3 side.
okay, -8/3. Yesterday only you got this answer, right?
Yes, sir.
So -8/3 or -10/3 will be the answer.
Yes, yes, sir. -10/3.
Yeah, -10/3. See
Yes.
how I'm approaching this problem. You guys can see, right? First of all, identify what kind of amplifier is this. This is a inverting amplifier. Okay, inverting amplifier. And you know that the potential at positive terminal and the potential at negative terminal will be same. So you can say 0 volt. What is the current flowing through this? The current will be 2 sin t minus 0 upon 1k. You can say 2 milliampere sin t current will be flowing here, right? You can write here 2 milliampere sin t. Very easy problem. So this current will not flow through op amp. It will go here, right? It will go here. It will go here. Understand?
Right.
Now, at this node, you have to apply one KCL. At this node, you have to apply one KCL. Okay. So the current is coming here. Now you need to know the potential across this 3K. Otherwise, you cannot find I naught. How can you find I V naught? We know that what is the output voltage of any inverting amplifier or gain. You can say V naught upon Vi is equal to minus feedback resistance, that is Rf upon R1, right? This we have derived. Also you can directly find the, okay, or you can say the voltage across this will be something, and then you can apply KVL, so you will get V naught, but directly you can find V naught, right? So from this relation you can find V naught. So what will be V naught here? V naught क्या हो जाएगा बताइए? That is
-4
2.
sin t.
Yeah, great. So V naught will be -4 sin t, right? And now you can find this current, okay, the current through this 3K, okay, that will be okay,
V0
minus
T
yes.
by 3.
So I3K will be what? -4/3 sin t. Yes. So now you can apply one KCL at this point. So KCL क्या हो जाएगा? I naught plus this 2 milli sin t, right? So by KCL, okay, at the rate output node, okay. So आप लगा लोगे तो यहाँ पर आपका I naught कितना आ जाएगा? You will get I naught as what?
So -10/3 sin t milliampere.
Yes, very good. So I think Sri Hari also has understood the procedure I am following. Okay.
Clear.
So it is not difficult, right? Any problem you can solve. Only two assumptions you have to keep in mind uh, for ideal op amp. And one more thing, guys. One more thing. Your op amp should not get saturated. What is the meaning of that? Your op amp output should not be larger than, okay, should not go beyond these supplies, okay, VCC you can say, or minus VCC, right? So your op amp should lie between, okay, your op amp output should lie between what? VCC, okay, VCC and minus VCC. Otherwise, here it will be saturated. So, okay, you have to keep this in mind. In this region, you have to operate your op amp always. Okay. Otherwise, your op
Yes,
amp will be,
sir.
yeah, otherwise, yeah, one question was there in GATE 2018. We will take up those questions. So that question was like, in the op amp they have given, right, like this. I'm telling you just a sample. It was very easy question, right? It was very easy question, and people think that Just I'm showing you what people think, right? So this is plus 15 and this is minus 15, right? And this is 31K and this is 1K, right? And this is what? This is 1 volt. Okay. Now, can you tell me what will be the output voltage of this kind of amplifier?
Minus 15 volt.
Yes, op-amp is ideal. In the question, they mentioned ideal op-amp. So what many aspirants think that, and they did not ask about V0. They ask about the potential at VA, this point. What is the VA value, right?
It's a potential, yeah.
Yeah. So in Haribari, like sir has told you in the class that, okay, sir has told you two assumptions, right? Inverting terminal potential at inverting terminal and potential at non-inverting terminal will be same. So what answer you will give? 0. Right? Directly you will give 0, na?
Yes, right.
Yes, definitely you will give 0.
Supply volt.
Yeah, supply voltage is 15, but you have to see these resistances. So see, this resistance is pretty high compared to this resistance, right? So definitely this op-amp will be in saturation. How? As we know that this resistance is what, this op-amp is what kind of op-amp? This is the uh, inverting op-amp, right? So minus RF upon R1, okay? You can say V in, right? So this relation is not valid for the op-amp if op-amp is going in saturation. Remember, okay? So this is wrong. Okay, this is wrong for the op-amp which is going to get saturated, because this relation you have got from the fact from two assumptions, right? Ki this potential and this potential is same. So in this case, what you have to do, if the op-amp is saturated, so if op-amp is saturating to positive rail, so output will be 15, and forget about op-amp. Then you calculate this, right? So can you calculate VA now? And now you can calculate VA, right?
Sir, actually,
So 0.5 volt.
So yeah, go ahead.
sir, I had one doubt, but I still didn't understand that that saturation. How can we identify?
Okay, great. It is a great question, right? Wait, I'm telling you. Wait 1 minute.
Okay, sir.
See, op-amp is ideal. It means that your gain, open loop gain is infinite. Okay. And as we know that op-amp output should lie between, op-amp output should lie between what? VCC, positive VCC and minus VCC, right? So
Right,
if
sir,
you're
right.
trying to calculate op-amp by considering this is 0 volt. Okay. So what is the output now? Output बताइए जल्दी से. Output will be minus 31 upon 1 into 1, right? So कितना हो जाएगा? Minus 31, right? Output will be minus 31. Okay. Understood?
Hello,
Output
sir.
will be minus 31. What I have told you here, the output should.
Okay, sir. Right.
Okay.
Right now, I have
Should
seen the slide.
not
I
go
think some network
beyond.
problem. I think.
Okay. Okay, great. And explain what I told you. See, your output should be lying between VCC and minus VCC. Okay. I have shown you this. This. Your input, see, your output should be between minus VCC and plus VCC. Okay. If you are going beyond, if you are increasing input, So your output will be what? Your output will be saturated. So that condition is known as op-amp went into saturation, and your op-amp will be have like a comparator. Remember, okay? So in that case, these relations, what minus RF upon R1 and all will not be applicable. ये सारी चीजें, these things you have to keep in mind, okay? Once you know, in the examination you will find question, so they will play with you simply. So if they will ask you what is the value
Yes.
of, so if they will ask you what is the value of VA, so don't answer VA equal to 0, okay?
Actually, whenever the supply voltage is given, then have to be cautious actually.
Yeah, it is a great suggestion. Yes, Surajit, yes. Whenever there is a supply voltage is given, and also the resistance value, okay, you have to focus on resistance value as well. After all, your gain depends upon the resistances connected, you know, around the op amp. है ना?
Yes.
So your VA will be what? Here, you can calculate VA now. So see how I'm calculating VA. I was 1K and 30 is uh, 1 volt. Okay. So forget about rating. Okay. Minus 15, right? So forget about op amp now. Just take a simple uh, uh, network. This is a network. This is 1K. You have to find the value VA here. And this is 1K. And again, there is the, you can say minus plus. Okay. 15. Right? So you have to find this VA. So this problem can be solved with the help of superposition theorem, right? Okay, you can solve this problem with the help of superposition theorem. You can deactivate one, go for 15, or you can deactivate 15, and so you will get the answer. So guys, can you solve this question, and can you tell me what is the answer for VA?
So 0.5
Srihari,
volt.
have you understood? Okay, 0.5 volt you are getting, right? Srihari, have you tried this question now? I think in your side there is a problem of network. Okay.
Hello, sir. In
Yes,
between,
have it.
I think in between I have missed a lot of things. Like a slide got updated and the voice
Yeah.
cracking issue. I don't know why.
Okay, my voice was cracking, right?
Yes, sir. Yes, sir.
Okay, great. So have you understood till here how op-amp goes to saturation?
I just need to refer once more because I was affecting with these delay issues.
Yeah, it's okay. Yeah, it's okay. Let me get back and see. See, the op-amp output should lie between these supplies. Okay, remember always. This is very important statement. Op-amp output should lie between the supplies given in the op-amp, right? If
Right.
output, yeah, if you're trying to apply virtual ground concept and you are getting the output greater than the supply, okay, so your op amp will be saturated. This is the saturation, right? Okay, your op amp will be saturated and it will be non-linear then, right? Here the characteristic is linear. I want this always, right? My op amp should operate in this region, right? So you need to keep output, you need to keep output within power supply. Okay.
Okay.
So
Okay.
in this question they have asked op amp is ideal and you have to find VA value. You have to find VA value. So in hurry bari, what do you think? Op amp is ideal, so VA is 0. How? Because there is a virtual, this is a ground, and this 0 volt will be going here, right? Because of virtual ground concept, right? But you have to also check output voltage because these supplies are given. Means you have to be slightly cautious about this. Understand?
Oh, okay, sir. Right now it's very clear because I have misinterpreted that resistance. Like it was 31K. I just saw 3K, and
Okay.
I didn't actually I really confused actually. But
Yeah, yeah, it happens.
because
See, so, Mhm. Yes,
under
yes.
it's a like if we apply that virtual ground, it will be under 15. So I thought how it will get saturated, or am I missing some real thing, something?
Yeah, it's okay. Right. So, where you have to focus, let me write those things, right?
Okay, so first we should
Always,
apply this virtual concept to check whether the is in saturation.
yeah, see, when supplies are given. If supply is not given, it's okay. Go wild, okay?
Okay, okay.
Blindly solve the question the way I have solved, right? So always check, always check, okay? Always check resistance values, right? Okay, resistances values, right? Whether they are high or low, right? If they are high means there is some trick, okay? Remember. And if supplies are given, to supply, okay? Supplies. Understand?
Clear,
So
clear.
if supplies are given means you have to test whether your op amp is ideal, I mean saturated or not. Then all those formula what you have learned right till now will be failing, right?
Right.
Okay. So let me take one more problem, which is very good problem. Okay, and the problem number 3, and you have to tell me whether it is non-inverting or inverting, right? This is plus, this is minus. Draw the circuit with me. This is your input, okay, and this is your R1, this is R2, this is V0, right? Can you solve these questions very quickly and tell me the output? Uh, yeah, this is R3. Tell me the answer, output voltage of the this op amp. Op amp is ideal.
So minus R2 upon R1 into K.
This is R3, right? R3. Yes.
So
So
it's
this
a
is what kind of
inverting
amplifier is this?
amplifier.
Yeah, inverting amplifier, right?
Inverting.
Yeah, great. It is an inverting amplifier, guys, and remember one more thing. Okay, so this is inverting, right? And there is a zero board, there is a zero board, right? So directly you can write the answer. I don't have any problem. It will be R2 by R1, right? R2 by R1 times V in. Very good. See, this R3 is basically a load, right? And load is connected to one single ground. That's it. So this is already we have
Yes.
seen this kind of a circuit, yeah. So don't get misled. That's why most of the time, whenever they will ask you that this kind of a question in the interviews, when you will go, suppose this is A, this is B, right? And this is grounded here, and there is a resistance connected to it, okay? And this is resistance, and there is a supply again, right? And there is a resistance, V0. Okay, these are the three resistances. Suppose this is R1, this is R2, and this is R3. Okay, right? They will ask you the sign of the op amp under negative feedback. You guys might be knowing that based on the how you decide there is a negative feedback. How you decide? Can you tell me? Hello.
Hello, sir.
Yes, sir.
How you decide there is an in this op amp? What kind of feedback is there? Can you decide
It's a negative feedback.
how?
So because output is connected, some part of output is basically mixed with the input section.
Yeah,
The
there is a
source.
feedback. Yeah, there is a feedback. But what kind of feedback is there? Negative or positive?
It's a negative feedback.
How you are claiming there is a negative feedback? Can you give me some yes. See, most of the places you might have seen, or most of the teacher they might have taught you that whenever we take output and connect to any terminal like positive terminal or negative terminal, that gives you the feedback, right? Am I correct? That will give
Yes,
you,
sir.
yeah, but that is wrong. Actually, that is wrong, right? See, like right now I have told you this is A, this is B, right? This is A and this is B. Now you are connecting output from both the side, right? From you are connecting to A as well, you are connecting to B as well, right? So now there is a confusion, okay? So don't worry, in your HAL or in gate examination, this kind of question will not be asked, but in the interview, definitely they will ask questions. So there is one procedure, right, to find the sign of the op-amp. Okay, so remember always, sign of the op-amp does not decide the feedback. Sign of the op-amp does not. Okay, decide positive or negative feedback. Okay, remember these things. Sign of the op-amp does not decide positive or negative feedback. Okay, this is one hint I'm giving you. And later, if you will be very curious to know about all these things, we will discuss, right? But for the present, we need to solve many problems. Okay, so two assumptions you have to keep in mind and you have to solve this. Now, let me take one more problem, guys. The next problem, that is problem number 4. That minus plus, this is the resistance here. Okay, yes, and there is a resistance again. There is a resistance again, right? Op-amp without resistances is very bad, okay, because it will be in saturation again. So there is a R, right? This is R again. This is R. This is R. Everything is RR, and there is a V1. There is a V2, and you have to find V out. So can you suggest me how you're going to solve this problem? Will you use KVL, KCL? What kind of a procedure you're going to?
So using superposition, can we do?
Yes. See, using superposition, it will help you to decide, okay, this is a non-inverting amplifier, this will be inverting. Superposition means
Yes, sir.
what? Killing one source and going with another one, right? So
Or
always keep
using
in using.
intermediate voltage uh, and applying in a virtual ground.
Yeah, but the superposition is very like it will behaves like a workhorse now. So go for superposition.
Okay, okay.
See, in the most everywhere you will find this kind of a question. They say that okay, apply KVL, KCL, right, and find the answer. But please, right, you can directly answer this question. See, by superposition means
Yes.
just forget this, right? Grounded. Okay, V2 is grounded, and the potential at this point will be what? V1 by 2, right? V1 by 2, and you know this is what? This will be now the what kind of amplifier? This is non-inverting amplifier. So directly you can answer the question, right? Directly you can answer the question. So V naught will be what? V naught will be V naught 1, you can say. V naught 1 will be V1 by 2, 1 plus 1, right? So it is V1 only. Okay. How I have got 1? Just I have divided this and this. Okay. 1 plus Rf by R1. You know this formula, na? V naught equal to V in, right? 1 plus RF upon R1 in case of non-inverting amplifier. Understand?
Yes, sir. Yes, sir.
So please always decide whenever you want to attack on the problem, any problem, whether it is gate or HAL or VARC exam problem, you have to decide, okay, which procedure will give you result in time, okay, because this time in the gate examination, very good question was there from op-amps, right? So all questions can be done within 40 second or 30 second, right? If you know this kind of a procedure, okay. So V01 you got V1. Now you deactivate this. Now you deactivate this and forget about that, right? Just yeah. Now can you decide what will be the V02? Yeah, again see everything is grounded here, so it will behave like an inverting amplifier, right? So your V01, your V02, V01 you have got what? V1 and V02 you will get minus V1, V2. So what is VO? V01 plus V02. What is this? V1 minus V2. So this circuit behaves like a difference.
Subtractor.
Okay. Yeah,
Subtractor.
subtractor. Yes, great.
Differential.
Yeah. It is subtracting, okay, it's subtracting two input, right? So it is a great circuit. Understand, guys, how I'm solving this problem?
Clear, clear, sir.
See, you can apply, see, there are many procedures, right? You can apply KCL plus virtual ground, all these things, right? But in case of superposition, what we are doing here is we are applying everything, but we are skipping all those intermediate step, okay? So that you will get the answer very quickly, right? Why to increase steps if you know the short okay, I mean these are not shortcut, I can say these are the technique, okay, where circuit designers solve the questions, right? Next question, right? Question example number 5 now. Find out the output voltage very quickly, okay? The way I have told you. V naught. This is 1, okay? This is 1K and this is 10K. This is 10K and this guy is grounded here. This guy is 2 volt, right? And this is 3K. Guys, op amp is ideal and you have to find output. Always consider the op amp is ideal.
Minus 2 by 3.
Yes. Minus
2 by 3.
your output is minus 2
Say
only.
2 volt.
Yeah, minus 2 only, na? Minus 2.
Yes, sir, minus 2.
Yes. Minus 2. Sri Hari, you are making mistake somewhere. Please check it out. Why are you making mistake of this kind? See how I'm solving the problem. Be confident, man. Be confident. The moment you will see the question, be confident. Okay. So this is V naught now. You have to compute the voltage at this point.
Yes, yes. Clear, clear. Now it's clear. Half.
This is V naught by 2. Got the V naught by 2. So you can apply superposition again. At this point, you can apply KCL or you can apply superposition. So I'm going to apply superposition by superposition. See how I'm solving the question in one line, right? KCL will involve many lines, right? So V naught you have to find V naught equal to, okay, wait. You have to find this point, this potential, okay? So you can say that the potential there is V naught by 2 equal to, deactivate 2 volt and allow this V naught, okay? So this will be 3 by 4 V naught, okay, plus. Now forget about this V naught, and allow this 2 volt, right? So it will be 2 into 1 upon 4. Okay. Both of you have understood this?
Yes, yes, yes.
This is superposition, right? Yeah, one line answer. But if you're going to solve with the help of KCL as well, this is also correct. How you will write KCL? Writing KCL. See, I'm writing KCL for you. This is V naught. This is 1K. This is 3K. And this is 2 volt. Right? And this potential you know again. This potential you know, that is V naught by 2. Okay. So apply KCL. So 2 minus V naught by 2 upon 3. Forget about K. Incoming equal to outgoing. That is V naught by 2 minus V naught by 1. Yeah. V naught now. Your V naught will be minus. Next. Based on finding op-amp fit in one line. I will tell you, how to find gain in single line. Okay, it is the next problem. Please write. Problem number 6. Minus plus. This is V naught. Okay, and this is minus plus 4 volt, right? It's given, and these are grounded, right? And this is 10K, this is 2K, and this is 3K. So you have to find V naught. So it is again one very good problem. Okay, what we can expect in the op-amp HAL exam from the op-amp topic. So op-amp is ideal. Okay.
So lower resistance value 2K and 3K.
This is 2K and this is 3K. Yes.
Okay, sir.
Dekho, how we are going to solve this problem?
Using a voltage divider, find that intermediate voltage V0 and
Yeah, exactly.
by 5.
Here you can find directly the voltage. So
So
this
20 by
voltage
3
will
volt.
be what? This will
V0
be
into
2 V naught by 5.
yes,
Okay. And this guy will go here. Yes. So you will
yes,
find current now. So there will be current, right? Yes, there will be current, and that current means you can apply one what? You can apply one AVL, right? So current will be what? Current will be 2 by here.
0.2 milli.
Yeah, you can find the current and you can decide answers. What is V naught now? Please tell. Please apply KVL properly. Take first sign, minus, plus, and then plus, right? Drop across this. Have you got the answer now? One line answer. V naught is?
So 25 by 6.
20 by 3,
25
right?
by 6.
Oh, 25 by 6 you are getting. That is 10K, 2K, and 3K, and this. So let me solve this, okay, for you guys. So the current flowing here is what? Okay, needless to find current, right? Because already the potential is available here. So you can apply KVL. So by KVL, if you want to find current, it's okay. But why we are finding current? Already we know the voltage across this 10K is this. So by KVL, minus V naught, okay, plus 4 and plus 2 V naught by 5, okay, equal to 0. So it will be what? V naught
20 by
minus
3,
2, yeah, equal to 4. So this will give you 20 by 3, right? So wait. Yes, Surajit, you have got the answer. V naught will be 20 by 3.
Yes, sir.
Srihari, have you understood this analog circuit? Analog circuit is one of the very beautiful subject. If you understand like this, I mean, do not solve anything blindly, okay? Decide, okay?
Sure, sure.
So have you understood this, how I'm solving this problem?
Yes, sir. I really understood the approach.
Yeah, very great. Now, the moment you will find next question, now you will think the way I'm thinking. And I have been thinking since many years. Right, and always I try every student in the gate classes that everyone should think like that, so they can make the difference in the analog circuit. Otherwise, they feel the analog is very difficult, right? In fact, electrical engineering student also, but you have to find V naught in terms of I1 and I2. Find V naught. Write down the question. Find V naught in terms of I1 and I2. I'm drawing the circuit. Please draw with me. There is minus, there is a plus. This is the current source. That is I1. Okay. And this is 1. This is I2. And there's a current source. V naught. And this is 1 ohm, right? Guys, you see here, this is 1 ohm. This is 1 ohm again. All the resistances are 1 ohm, okay? So what you have to find here is, you have to find, this is I2. This is I2. This is I2. So there are 2 op amps connected back to back, okay? Find V naught in terms of I1 and I2. So by looking at the circuit, you would be able to find the voltage here, right? What is the voltage at this point? You can say V naught 1 will be. What is the voltage at this point?
So V naught equal to I1 minus I2.
Yes, V naught equal to V naught 1. Acha, V naught equal to what?
I1 minus I2.
Yes, I1 minus I2. Very good, very good. This is a current subtractor, right?
Yes, sir.
Uh, Srihari, have you understood the approaches? What I'm trying to say?
Yes, sir, clearly.
हाँ, so V naught one तो आपको पता चल गया होगा. V naught one will be here minus I1, right? It will go here and it will go here, right? So you can see here, both current will be inverting again. So answer will be I1 minus I2. After all, this is a inverter circuit. This is also inverter. Right?
Yes, sir.
Here the source is I1 and here the source is this total. Great. Next problem. These kind of problems you have to solve always, and you can cover all previous year questions. So next problem is like very good problem. See, on the circuit itself, you can solve the problem, right? This is, think about the problem first, okay? Identify whether it is inverting, non-inverting. Don't blindly apply KVL, KCLs, right? 1 milliampere, 3K and 2K, right? And this is the resistance again connected, 1K, okay? 0.5K. You have to find V naught. Both of you, yes. Suppose this is a HAL problem, right? And it is of 2 marks, suppose. Then what you will do? V naught. And you have only 10 seconds. Or you can say you have only 30 seconds, 20 seconds. How are you going to solve this problem?
So 0.5 volt.
Okay, your answer is what? 0.5?
5, sir.
Yeah,
0.5.
but that is wrong answer. The answer will be minus 1.5 volt. Okay,
Okay, sir.
So
where are you failing? Huh?
current is not entering the op amp, so it gets divided to. Is that the approach? So
Very good. See, here you have to make assumption that the potential across this is about 0, right? Because the difference we always take very less. Okay. So you can see here, you can consider that these 3K and 2K are in parallel, right? So you can, compute the current now. So what will be the current here then? Can you tell me? If two resistances are in parallel like this is 2K and okay, and this is 3K, right? 2K. Let me erase this.
193 by 6.5 maybe.
Hmm. So this is 1 milliampere. So can you tell me the current will be flowing through 3K? The current will be here, that is 2 upon 5, right?
Right.
2 upon 5, yes, 2 upon 5 milliampere. That is about what? 0.4 milliampere. Okay. So current is 0.4 milliampere. Here, 0.4. And the current will be flowing here, how much? You can subtract now. 1 minus 0.4 means 0.6. So this current will be flowing here as well, right? So you can find out plus to minus the voltage drop across this, that is 0.6 here. The voltage across this 0, and the voltage across this will be what? How much? Can you tell me? Voltage across this will be how much? Anyone? Oh, okay,
So
okay.
0.2 volt.
Yes, direction is correct or not correct, right? This direction is not correct here. Please correct this. 1 minute, right? Here you have to be very cautious, right? So this is 0.4, so here it will be 0.6 milliampere. Current is flowing like this, okay? So you can apply now, you know, plus to minus, you can say this is 0.6, and now this current is going like this, okay, 0.4, है ना? So now you can apply one KVL like this, है ना? So the answer will be minus V naught. The potential drop across this is how much? That is minus 0.2, okay?
0.27.
Okay, potential across is 0.2. Let me check
Yes,
the,
sir.
yeah, let me check the values which I have written here is correct or not. Wait 1 minute. Yes. Yeah, so your answer was Srihari 0.4 last time. I actually told the answer wrong here. I got to see next question and I answered like I just saw the answer, okay, in the notes. So yeah, it's okay. Now it is correct. Answer what you are getting answer here? That is not negative 1.5, right? Answer will be different. Okay. Okay. So what answer you have got, Srihari, last time? What 0.5, right?
So I was actually thinking a little bit of after I have seen that two parallel three. I was thinking something else from that
Okay,
moment.
okay, okay. How I have made two parallel, 2K and 3K, right?
First, actually, I got initially I got that approach that it gets divided, but after that, this two parallel three, I was just looking. I had something off actually.
Okay, okay, great. See, what I have made assumption here is that guys, forget about that negative 1.5 answer. Okay, answer will be different here, right? Now we are solving, so we are getting the answer, right? So he has this kind of a problem. Wait, I'm taking next, you know, just I will tell you here what I have applied here. See, this is the resistance here connected, okay? And this is the resistance, right? This is a problem, right? This is a problem. So the current here is going to this node, right? So this current will be divided here. Okay, this current will be divided in these two branches. So what I'm considering here is the 0 volt. Okay, because we always consider the input, the difference between two input of the op amp. Okay, should be very small, right? So what I have considered here is the 0 volt, means these 2 points are at same potential. Understand?
Okay, okay. Finally, it will reach there. Okay, okay, okay.
So if 2 points are at the same potential, it means that they are in parallel. Okay.
Okay.
हाँ. So अब आपको, now you might have understood, right? So here the current is 0.4 milliampere, and here the current is 0.6 milliampere. You have to be slightly careful about, see, find the voltage drop and apply KVL, right? This is 0.6 volt, and here the drop will be 0.2. Now you can apply what? You can apply KVL like this as well. So you can apply from here to here, here to here, here to here, like this. So I'm just 0.6, okay, plus 0 volt plus 0.2 plus V naught equal to 0. So V naught will be 0.4 volt.
Oh, yes,
So in single line you can get the answer. Okay, Sri Hari?
yes, that's clear. It's clear.
Sri Hari and Surajit, have you understood this?
Yes, sir.
Please forget about that 1.5 what I told. Okay. Because in the problem answer was given, so I thought okay that, but the answer is 0.4 exactly. Okay. let me take next problem, and the same kind of problem I'm going to give you now. So please try both of you, right, this problem. Now in place of current source, I'm going to connect, potential, right? Voltage source here, some fixed voltage source, 1 volt, right? Very good problem is this now. So this is how we solve the problem, and this approach is called the by inspection approach, right? We are making inspection before attacking to the problem. Okay, so this is 3K and this is 2K, right? And this is 1K and this is 0.5, and this is minus, this is plus. So guys, whenever you try to solve the problem now, don't go for bigger steps. Okay, try to minimize this solution steps. Okay, 2-3 steps or 1 step maximum, right? Yes, go find out the V naught. Both of you try this question. Okay, if there is an interaction, so it makes the class very interesting, and we understand concepts very clearly through the problems.
So can we take the lower point as 0 volt, and with respect to that 1 volt is upper point?
Yeah, go ahead. Yes, definitely you can take here 0 volt, and you can apply 1 KVL here, considering the current is I, right? Understand? You can find the current.
Yes, sir.
Yeah, you can find the current. So you will get this current will be flowing here, here, and the same current will be flowing here as well, right? What is the current here? I directly you can write I equal to 1 minus 0 upon total. Okay, how much is total? That is 5K. So how much it is? 0.2 milliampere. Understood, Sri Hari and Surajit?
Yes, sir.
So this current is flowing 0.2 milliampere here. So this is plus to minus. So what is the voltage here? That is 0.1, right? And the voltage drop here is how much? Plus to minus 0.2, right? So now you can apply 1. Now you can apply 1 KVL, you will get the answer. Understood, everyone? See, so I'm going like this. Yes.
So, if it's a blunder, I'm really sorry. If I take the lower as -1, and then moving through like this 2K and 1K as voltage divider, in getting that point, the input terminal, positive input terminal voltage as -1/2, and apply virtual ground and use the same -1/2 as the voltage of negative terminal.
So how much you are getting answer then?
Hello, sir. Hello.
So
Hello.
getting negative 0.3. My voice is audible? Surajit,
Hello, sir. Right now I
have you
heard you.
Yes, sir.
understood this? Yes. Go ahead. Yeah.
Yes, sir.
Have you understood this? 0.3 volt. Answer will be minus 0.3 volt. About.
Yes, sir. Minus 0.3.
Because you will go like this and
So,
you will get the answer. Ah.
sir,
Yeah,
I
yes,
think
yeah, Srihari, yes, go ahead.
sir, I think I got the same answer right now by using this way also.
Minus 0.3? Then that is okay.
Like
See, if you are getting answer correctly means,
like actually in the positive input by using the voltage divider we'll be getting minus 1 by 2, that means minus 0.5.
yeah,
That minus,
definitely. See, this is like this, right? So we are considering like this. So you can consider find the voltage here. Okay, voltage you can find, no problem is there. No, what is there? But find applying voltage division and then getting current, right? Why not to get direct current, right? If we can apply KVL, okay?
yeah,
So yeah, so the approach you have to follow, which will reduce the minimum steps, okay?
sure.
You can think, yeah, great. Your thinking is good, right? So the way we are trying to solve the problem here is we are not involving network analysis here, right? So don't consider that if you're not if you're good at network means you can solve analog circuit properly, right? You should know you in analog circuit you have to decide, okay, where those thoughts can be applied. Hmm.
Uh,
Okay.
yes, yes.
Yeah, don't make analog circuit as network theory. So see, these questions we are solving in 2 steps maximum, right? So this is how we have to solve the problem. And whenever
But
you will go for the interview, yes.
but I thought that was easy for me. I think because of the values of the resistance were small, we can just
Yeah.
calculate it mind actually because I'm not having a pen and paper, so shortcut. I got the shortcut
Oh,
like
now
this
you
only.
started playing in the air, right? Okay, great. So see, without pen and paper, you're answering the question. It is very great thing. Okay. So see, what I would suggest here is that whatever procedure you like, follow that. Okay. The way you are able to solve the problem will work in the examination day, right? The way teacher is teaching you will tell you, if you accept that method, that is good. If you're not liking that, I mean, that method is also fine. And but yeah, remember that the method you are following should not take much time. Okay.
Yes, sir. Understood.
My main objective is through these sessions on analog is that you will not find these kind of a session on YouTube as well. I mean, in any YouTube. Okay. Main objective is to minimize the steps. Okay.
Yes.
Mm. And also do not lose the flavor of analog.
Sure, sir.
Yeah. So write down the new topic because already we have done many questions. So the buffer, actually already we have talk about buffer. So now we will talk about buffer, or you can say the voltage follower. It is also known as the voltage follower. Voltage follower, or you can say the unity gain amplifier. Unity gain amplifier, right? So buffer or voltage follower or unity gain amplifier. So buffer, as I told you that we discussed about buffer. Buffer was basically like voltage follower, okay, where the input and output voltage will be same, okay, and the voltage gain will be 1, right? In case of current buffer, the current gain will be 1. But if if voltage gain is 1, then what will be the power gain? The power gain will be the current gain only, because any buffer will be having, suppose voltage buffer is there, so it will be having high current gain, okay, because voltage buffer will be having unity voltage gain, right? So remember this. And what is the main application of buffer? In the examination, they will ask you The voltage buffer, what is the main application? So for the case of impedance matching, right? It is an impedance matching device. What is this? It is an impedance matching device. You have to write impedance matching. Okay. Device. Buffer is used to match the impedances, right? It is an impedance matching device which connects high impedance source to low impedance load. Which connects high impedance source to low impedance load. Okay. Load. Understand?
Yes.
See how I'm what I'm talking here is that you might have seen in control system, right? Suppose there is two RC circuit, they are cascaded, right? Okay, these are two RC circuits cascaded. So if you want to find output here, and so you can't apply the voltage division rule if you want to find voltage across this. So you can't apply direct, right? Because this will work like a load. Okay, it will create the loading effect. Okay, it will create the loading effect, right? If you want to find the transfer function of this network, right? So you will have to Theveninize this, and then consider all, right? Means this network also you have to what? You have to uh, there will be a loading effect. So if you are considering the gain of this uh, part of the network, okay, and if you're finding the gain of this part of the network, and if you're multiplying both, okay, so that is wrong. Okay, that is wrong. So sometimes in the gate also they have asked question. So sometimes people call it 1 by 1 plus SCR whole square, right? But this is wrong. Okay, why? Because there is a loading effect. Okay, because of this part of the network, okay, on part one, okay. But if you will connect in between these two network, okay, one op amp, or you can say one voltage buffer, right? So you can find easily the transfer function or anything, right? So basically or you can say whenever two blocks are cascaded, suppose one is common collector, and one is common base, right? So you can see here already we have discussed these kind of common collector and common base, right? So what is the input resistance of common collector? Anyone? What is the output resistance of common collector?
So
What is the
high
input
and low.
resistance? Huh?
So input
Yes.
impedance high and output is
High.
low for the
Yeah,
common
it is
collector.
low, right? Yes, it is low. And what is the input resistance of this guy, common base? Common base we have like a CCCS, right? It is low only, right? Okay, so
Yes, sir.
there is no mismatch, right? Is there any mismatch? There is no mismatch. Means output resistance is we having like a input resistance of common base. Okay, so there is no mismatch. Okay, so you don't need any buffer now in between these two cascaded okay amplifiers, right? Why we cascade amplifiers? We will learn why we cascade amplifiers to increase the gain, right? According to our requirement. But there should not be mismatch of the impedances. If there is a mismatch, then what will happen? Let me connect one mismatching condition, right? Suppose there is CB here, right? And there is a CC here. Now you see. You see here, again, this is high and this is high. So it is okay, right? Whether you put CV first or CC later, okay, everything is right. Now you can take common base plus common emitter, right? Or anything. So common base output is high and common emitter, the input is in intermediate range, not that high. So there will
Yeah.
be mismatch, okay? There will be mismatch. So this is what the application of buffer is. We will learn the cascade connection. We will learn the cascode one as well, right? All these things in BJT part. Don't worry, just I'm telling all these things in brief here. Okay. So have you understood what is the meaning of buffer?
Yes, sir.
Impedance matching device which connects high input, high impedance source to low impedance load, right?
Clear.
It's okay.
Yes, sir.
Now, with the help of
So any other application of buffer?
yeah, that is what the buffer is. If you want current gain high, okay, okay. If you want directly, if you want to connect input to the next stage directly, you can apply this. There are various applications, okay. For the moment, impedance matching is one of the highlighting one, okay. So this is what the buffer is, right? Suppose this is a buffer.
So any delay is created when the buffer is connected to a circuit.
Yeah, buffer, yeah, any buffer is connected, so there is a delay. Yeah, it happens in digital circuits and all, right? Here it is analog, right? So definitely there will be some drop and everything. So delay and all we do not consider, in analog, right? Have
Okay.
you ever discussed in case of amplifiers any delay kind of thing, right?
No, just just had a doubt. Yes, sir.
Yeah, if see delay happens when there is some capacitance and everything, right? Some time constant. Right now we are not considering any capacitance and all. So it's okay. Just remember that buffer, the maybe voltage, the question can be like this. Voltage buffer has these properties, options: input resistance high, output resistance low, impedance matching device, all these things, right? So you have to mark these things. Question will be very easy in HAL. Do share your experiences of analog circuit after coming out from the examination, all right?
Okay.
So this is what the buffer is. You can write here, that is V1 and this is V2, sorry, V naught. Okay, V input. It is V input. So directly you can connect, whether you connect R here or not, no problem is there, right? So let me write one table here, that is voltage buffer. This table you have to keep in mind for the HAL exam and the current buffer, right? See, I have got PDF as well, everything, but I'm writing everything so that you guys feel much better. Otherwise, I can put the book here, right? Then you will not be able to understand, right? So the input resistance, talk about input resistance here. Output resistance, AB, AI approximately. Okay, AI, AB, AP, AP. Guys, can you tell me input resistance of voltage buffer? High. Output resistance low. The great example is op amp only. AV 1. AI high. This will be AV into AP means, sorry, AP into AI means this will be AI only, right? because AV is 1. In this case, current buffer input resistance is low. This gap will be high. This is 1. This is high. And this gap will be equal to AV. Understand, everyone? So please remember these things. Please remember these important points. Please remember these important points. Okay, from here. Note it down.
So can I see that buffer circuit again?
Yeah, buffer circuit. Buffer circuit is very easy. What
Okay.
buffer means? What? V naught equal to V in. That's it. Buffer. Unity feedback is there, no? Feedback is unity. Means the gain V naught by V in should be 1. Okay, at low frequency, this is happening. At high frequency, okay, now we will talk about something important. Okay, guys, have you understood this now?
No. Yes, sir. Yes, sir.
Yes, sir.
Chalo. So write down the new thing which I will be talking. But before that, let me build some current sources, right? Because these current sources are very important. So build sources. Building current sources means we want to build good current sources, right? What is good current source? What is good current source? The current source is a good current source. Not change its terminal current, right? No matter whatever voltage you apply, it should give you the constant current. Understand? It should give you the constant current.
Yes, sir.
That is a good current source. Okay. Yeah. I mean, that you might have seen in case of BJT as well. This kind of a characteristic, right? So this is not the good current source, right? Good current source is this, where the current is constant, right? Ideal current source, this kind of a current source we want. I versus V. This is a good current source, right? Why we need current sources? What is the need of that? Because we want to realize one important application of the op-amp, that is integrator. Okay. Now we will bring capacitance along with the resistances, and the location of capacitance where we are going to put. If we will put the capacitance in front of the op-amp, it will behave like a differentiator. If we will put, or interchange the feedback resistance and the capacitance, and if we will place the capacitance across the op-amp, that will behave like a integrator, right? Miller integrator. So this is
Yes,
how
sir.
we have to identify as well. Keep in mind, if op-amp, if the capacitance is in front of the op-amp, so that is differentiator. Understand? So
Yes, sir.
identification is very important. Yes. So wait 1 minute.
Also, input impedance of the current source should be high, na? When we design.
Yeah. Input resistance, definitely internal resistance of the op-amp, sorry, current sources are high only, right? Internal
Yes,
resistance
sir.
of the, yeah, definitely not input, we will call internal it
Yes,
is, right?
internal resistance. Yes.
Yeah, so I want good current source like this. Suppose this is a current source of 1 milliampere, okay, and there is a load, right, connected to it, right? See how I am approaching. This is a load, right? And load is varying from 1K to 5K, right? Load is varying from 1K to 5K. So your current will also vary. Can you tell me? Can you comment on it? This 1 milliampere will vary or not?
No, sir.
Yeah, it will not vary, right? So this current source can be built with the help of op-amp. Okay, see how I'm drawing. suppose this is the op-amp and the mode and the configuration which we will take up is the inverting mode, right? So this is what the very good current source. Okay, this is 1 volt, this is 1 kilo ohm, right? And there is a load. Okay, V0. Okay,
Yes, sir.
we are varying this. This is 1K to 5K. So guys, can you tell me, can you accept this is a current source? Yes. How? Because there is a
Yes, sir.
0 volt. So the current flowing through this is 1 milliampere, right? And this, whether you change 1K to 5K, right? This resistance, this current source, this is a current source, right? This is a current source. Okay. So
Okay,
if you are
so
connecting, yes, yes.
practically, actually, this realization will be stable or not, sir?
Practically this, yeah, definitely. See, stable means what, in what sense you're saying?
Like we are actually applying this virtual ground because it's an ideal op-amp concept.
Yeah,
So
yes.
in practical, any change is there?
In practical, whenever the gain is pretty low, right? Gain is pretty low, right? Then you can't apply virtual ground concept. Then you can't say this is a current source, right? Right now it is a current source because this will give you constant current source. It is not the normal current source, it is a constant current source, right? And we are designing constant current source so that it can charge the capacitor linearly. Okay, it can charge the capacitor linearly, because
Yes, sir.
in case of integrator there will be resistance and there will be capacitance. Okay, so unless the constant current source, constant current flows through the capacitor, it cannot charge linearly. Understand?
Okay, okay.
Is regarding stability and all, we can't comment here, right? Because with what sense we are commenting, right? We are just trying to build good current sources and the ideal current sources.
Okay, okay.
In because in reality we can't get constant current source, right? You can see BJT as well. That IC, okay, collector current is very bad I mean very sensitive to very bad parameters like beta. Okay, beta makes the transistor very bad. Okay, that's why nowadays you will not find any questions from transistor in gate exams. Okay, from BJT basically.
Sir,
Since
current
it
mirror circuit with MOS,
yeah
that will give, I
yeah
think.
using MOS, yeah, using MOS, definitely using MOS. So we will create load as well now. These loads are also very bad
Yes,
sometimes. Okay, so we will create active load using MOS only. Okay,
yes, sir.
not bipolar junction transistor. The reason I've told you, beta makes the transistor very bad.
Okay, okay.
Understand?
Yes, sir.
Yeah. So constant current source, 1 milliampere is flowing, right? So see, we are starting with network and we are going to analog circuit. So you have to, whenever I will say constant current source, so draw this. Okay. Okay.
Okay.
Yeah. And which mode you have to follow? The inverting mode, right? Then only you can create constant current source, right?
Right.
Right. It's okay. So let me put here now the topic Miller integrator. Miller integrator. Okay. Hmm. Now you will understand Miller integrator. So now guys, you can yourself draw the circuit without looking at the screen as well, right? If someone is going to ask you, Sri Hari or Surajit, can you draw the integrator circuit? You will say, yes, sir. How? You start with network analysis, network concept. This is a current source, right? And in place of resistance, put this guy. Okay. In place of resistance, put this guy. Okay. So now there is a constant current source, right? So it will flow through this, right? And the voltage across will be VC, है ना? Voltage across will be VC. So what is VC here? VC equal to 1 by C integration I dt. Okay.
Yes, sir.
Yes. So now VC equal to what? If I is constant means I by C into T. This is what? So if you draw this voltage, it will charge linearly like this. Okay. The slope is I by C. This is a basics. This is a basics. Okay. This is just a basics. But now I want to, this. So as I told you, in case of in case of this, you can bring op amp into picture. So we can bring op amp into picture. So I can visualize with the help of V by R. So we will put V, we'll put R, right? And we can put switch as well, right? No problem. And here the op amp should be in which mode? Inverting mode, right? Remember always,
sir.
don't make mistake in the examination. Most of the instructor also they make mistake, right? Because they know only what KVL, KCL, Ohm's law, right? Most of the aspirant make mistake. Always check circuit is correct or not, right? But in the gate examination you will get correct circuit only, don't worry. This capacitor should be placed here and this is V0. Okay, so here you can see this is C, right? And this switch is closed at t equal to 0. Okay, so I is what? Suppose t equal to 0 and switch is closed, and so I will be constant current. I will be V by R, right, which is constant. Okay, so your capacitor will charge, current will flow I, and here V naught will be what? Minus VC, right? Your V naught will be minus VC. V naught will be minus VC. Okay.
Yes.
So if your capacitor is charging like this is VC, your V naught will be going like this, right? Negative slope will be there, right? So you have to keep this in mind. This is the basics of integrator. Okay. Capacitor okay in place of feedback resistance, right? So this will be known as integrator. And if you exchange, right, interchange RF and C, so what will happen? It will give you differentiator, right? So differentiator, write down the differentiator. Can you draw differentiator? This is the differentiator. This is V in, this is V out. Okay, guys. Differentiator, have you drawn the differentiator here? Yes, respond.
So,
Yes, sir.
Uh, yeah.
what were you asking actually? Sir?
Have you drawn this differentiator circuit without looking at the screen yourself?
Yes, sir. Yes, sir.
Yeah, now you should not face any problem identifying differentiator circuit. So you can find the answer using Laplace transform. This is 1 by CS, right? You can apply and you'll get the output, right? So output will
Yes,
be
sir. I used to
differentiators.
remember this thing.
Okay. So you can apply and you can get the answer differentiator circuit. So output will be what? Output will be V naught equal to minus RC dV in by dt, right? This is dV in by dt. So what is this? This is a slope, right? Understood?
Yes. Sir.
Yes, sir.
Now, suppose this is a question asked in the GATE examination. Okay, GATE, I think last year only they have asked questions. So two capacitor, if you remember this, right? And there is a resistance. This is V naught. There is a plus 12 volt and there is a minus 12 volt. Okay, and they have connected one step here. Okay, they have connected, this is 20 millisecond and this is 5 volt, and you have to find the output, find output, right? They gave some
What?
values. This is C, okay, and this is R. You can take anything, right? 1 kilo ohm, whatever you want to take, right? And C you can take 1 microfarad. So can you answer the question?
So it goes into negative saturation.
Yeah, exactly. Because the after all, output is what? If you think that this is a differentiator circuit, then you are wrong. Okay, because the moment you will apply, this, your capacitor will be short circuited, right? And the
Yes, sir.
capacitor will be short circuit. So directly the voltage here is high and the voltage here is low, right? So this is high and this is low. Okay, if you are directly connecting this, so this behaves like a comparator. Okay, this behaves like a comparator. After t equal to 0, okay, after t equal to 0, this will behave like a comparator. Understand? Okay, so answer will be
So,
Yes,
yes.
sir.
so why the capacitor got short circuited, sir?
See, initially the capacitor is having 0 voltage, right?
Okay, okay, sir.
Before the switch, yeah. So it is short circuited, right? And after the switch, the capacitor will continue to behave like a short circuit, right? Initially, you have to consider
Yes,
that.
sir.
Huh?
Yes, sir.
Initially,
So I
yeah.
think question maybe it is out asked to find the voltage at 0 plus maybe
Yeah.
t
Yes.
equal to 0.
Yes, at t equal to 0 plus. Yes. Very good.
Okay. Now it's
Actually,
clear, sir.
yes, I'm just the topic what I'm discussing here now. I'm recalling myself actually. That's why.
Yes,
Okay,
Okay.
sir.
sir.
Transient,
Yes, sir.
it's okay. Steady
Yeah, I
state.
will bring questions, actual questions in the form of PDF. Don't worry. Right now, I don't. I mean, I'm just teaching some concept as well. Na? So anyway, Sri Hari and Surajit is able to recall. Right? So at t equal to 0 plus, it will behave like a comparator. Understand?
Yeah, so now it's clear, sir.
It was very easy question, 2 marks.
Okay.
Most of the
Yes, sir.
candidate made mistake here, right?
Right, sir. Right.
So
Yes,
answer
sir.
will be -12. Okay, so this was all about today's class. I discussed about many things, op-amp, right? And integrator, differentiator. We discussed many problems. I told you various, you know, various methods how to apply. So you have to keep in mind the superposition is the very important method, right? Superposition, right? Always keep in mind this superposition. And next in the next class we will discuss about input resistance and output resistance, how to find input resistance and output resistance of op-amp. Okay, and then we will discuss about after input and output resistance we will discuss about Miller effect. Okay, so Miller capacitances and all Miller multiplications, and we will take one example for finite gain. If op-amp is having finite gain, so how to find output voltage. Okay, so after discussing all these things, we will start diode application. So because linear part is over, right? Now we need to bring some non-linear element. Okay, so linear diode application we will discuss tomorrow. And after diode application, we will again get back to op-amp plus diode. So we'll discuss about log amplifier and all those things. Understand? So this is my
Yes.
flow. Yeah. So because I always teach content as per the necessity, so that it could be very interesting to the student. Okay. But keep in mind the syllabus. The syllabus is diode and everything, right? This diode, flipper, clamper, and rectifier. Okay. So now they have made the syllabus very concise, but you have to cover everything. Understand? It's okay, guys. So we will meet tomorrow according to our time. Thank you so much. If you have any doubt, please ask.
Sure, sir. Sure.
Doubt.
Thank you very much, sir.
Right now, if you have any doubt, you can ask. I can give 5 minutes more.
Everything is clear about today's class, actually.
It's okay. Thank you so much. If you have any doubt, do ask. Do not get hesitated. Uh,
Sure.
the doubt should be, according to our competitive exams only, right? It should not be beyond the PhD kind of thing, because I will tell you, if that kind of a doubt is there, it's okay, but you have to mainly learn from this session is problem solving skills and how to maintain the flavor of analog, right? Do not lose it. The main
Yes.
objective is that, yeah. Okay, so we'll meet in the next session. Thank you.
Thank you.